Okay, gentlemen, what is today's date? It is, what is it? Wednesday, the 13th of November, 2024. Pete, what number are we on?
SolderSmoke 254. Crank it in, Robert. Crank it in, Ralph.
Crank it in, guys. It's good to be back. We're trying to get back on the regular schedule here, the regular routine. And, because we were kind of lax, because I was moving around, it's mostly my fault. But we're going to try now. I have a computer in the Dominican Republic. I have a good connection to the internet, so I think we'll be able to do this more regularly. Anyway, the opening, we have some disturbing news from Australia. Disturbing. I got on the radio the other day and I managed to work Victor Kilo 5 Radio Sierra VK5 RS, Ivan, down there near Adelaide. Now, this is not all that unusual. I work Australia all the time, thanks to the hex beam, which we'll talk about in a few minutes. But Ivan asked me about my antenna, and I proudly told him I have a hex beam up on the roof. And he said, "Oh man," he said, "I love that antenna. I love the hex beam. I had one." But then he said something that really blew my mind. He said, "It was eaten by cockatoos." Now that is an Australian problem. Holy cow. You would put up a hex beam, but you can't because the cockatoos are going to eat it, right? So listen, this made me think all those guys out there who are whining about their homeowners association won't let them put up an antenna, stop whining. The problem could be a lot worse. Your
Yeah.
antennas could be consumed by cockatoos. That is so Australian. It could be much worse. So just look on the bright side. We don't face a threat from cockatoos. All right.
You
Well,
know,
here,
you'd
here,
almost
here. Go ahead, Pete.
you'd almost think it was kangaroos that was the problem, not cockatoos.
Somehow the cockatoos are. It makes it more exotic. Or maybe they were. If it was eaten by vicious Australian spiders of some sort. But cockatoos are pretty good.
Cockatoos are good, although here in Virginia we have the large woodpeckers, and they could do some pretty good damage too.
Yeah, but apparently Ivan was saying that what the cockatoos do is they don't eat the wire elements of the hex beam. They go for like the cord that separates the driven element
Bungee
from the
cord.
reflector. There's a little bit of cord there that is a very precise length. So apparently they sit on the wire element, and then they chew on this thing. And man, if you snap a few of those even if you snap one, the whole thing goes kabloo. It turns from an upside down umbrella to something looking bizarre. So anyway, cockatoos. Hey, another threat. This was another threat that popped up, and we became aware of it on YouTube. Fake wires from China. Now, we're used to all kinds of fake parts from China, but fake wires? Holy cow, this was new for me. And there was a video put out by a guy named Matthias. Apparently, he's got a lot of videos. Um, and I have put a link to it on the SolderSmoke blog. So if you want to take a look at Matthias's video, go ahead onto the SolderSmoke blog and you'll see it there. But it was about clip leads. This guy, Matthias, was looking at clip leads, which is a very kind of esoteric electronic part. The guys who listen to SolderSmoke are probably the only people in the world that really worry about the quality of clip leads. Here we're worrying about it, right? But I saw this thing and I said, wow, our sponsor is Parts Candy. Carlos makes clip leads. So this is like directly relevant to us. Holy cow. So I wrote to Carlos and asked him about this. And he sent back some really good information, which I have up on the blog. And you could check it out. He really responds. The wire he uses is not fake. He does not use the crimp. He does not scrimp with a crimp. He actually solders those wires onto the clip leads, and he even makes a comment about the metal content of the actual alligator clips that he uses. And he points out that if somebody has a special requirement for a really low resistance clip, even the alligator clip, he will come up with copper clips for the buyer. But anyway, I take this opportunity to point out that if you do want to buy some clip leads, some test leads, buy them from our sponsor, Parts Candy. Don't scrimp with the crimp. There you go. And oh yeah, I have a link on the SolderSmoke blog page. But even if you forget that, just go to Parts Candy, one word, Parts Candy, one word.com, and that'll take you to Carlos's site. Guys, we got to talk about.
Hey, Bill, before you go on, it's
Yeah.
a good idea not to use Carlos's clip leads as dummy loads. It's only 12 milliohms.
For that, you need one of the Chinese clip leads.
Yeah, yeah. I mean,
Because
you smoke that thing.
one of the things
You'll
that Matthias
smoke
does
that
is
thing.
it's kind of cool. He puts some current through the wires and he gets like an infrared camera and he takes pictures of it and you can see the wires glowing hot.
Yeah.
Not supposed to do that. All right, guys. Another thing I want to talk about. I have appeared on Ham Radio Workbench.
Ooh.
And this all it comes, as is many things in life, it comes from guilt. Because a while back, I was watching listening to Ham Radio Workbench, and they had a program that was billed as rejuvenating old radios. And I figured, man, this is right up our alley. Dean has rejuvenated a broadcast receiver. Pete has rejuvenated many rigs, including the HW101 many. I'm surrounded by old rigs that I'm pretty much in a constant process of rejuvenation. And I figured this would be all about how to go in there, how to change the caps, how to oil it, how to do all the many things that you have to do to keep one of these old pieces of gear working, right? No, wrong. That's not what they talked about. They had some guy on, and I'm sure he's an expert in his field, but all he talked about really, in my mind, was pulling all of that good old boat anchor guts out of the old radios and stuffing in a whole bunch of digital stuff, digitizing them, making them into SDR radios that are like encased in a box that makes them look like a Heathkit HW101. And I didn't like it. I might have been having a bad day or something, and I sent a note to the Ham Radio Workbench, and I might have been too harsh. It happens. It happens to all of us. So when they came to me and they said, could you come back and we'll talk about it some more? I said, okay, yeah, let's do it. So last week I had an appearance there, and we talked a little bit about rejuvenation and the different ideas we have about rejuvenation. And then they made a mistake. They said to me, so, Bill, it's our understanding that, well, I guess maybe the best way for a beginner to proceed would be to start with a kit, right? Don't you agree? A kit? And I kind of said, no, that's not what we say. We in the SolderSmoke blog world, we kind of just say, well, the kit, you're probably not going to learn a lot. You're just going to stuff parts on a board, and then you're going to just have parts stuffed on a board. And we always say you begin with a real homebrew project where you go out and you acquire the parts, you make the board, you put it together, you build a thing, like with the Michigan Mighty Might. And so, yeah, well, that's kind of interesting. Afterwards, it occurred to me, gentlemen, what we should do is we should throw down the gauntlet at Ham Radio Workbench and challenge them to actually do some real home brewing. So that's what we're going to do right here, right now. We challenge Ham Radio Workbench team, the whole crew of them. There's 5, 6, 7 of them. All of them should build the direct conversion receiver that Dean and I tried to get the students at the local high school to build. All of the info is on the blog, on Hackaday. It's all there. All the schematics, all the detailed build instructions, stage by stage. You can build the whole thing. Now, if you do this, the first thing that we had the students build was the oscillator, the little oscillator in there. So that will take care of the requirements. Once you build that stage, you will have built a ham radio transmitter. Woohoo! But then don't stop there. Continue on. Build the whole receiver. You guys definitely have the capability of doing this. You have workbenches. The students we were working with didn't have any workbenches. You have workbenches. The name of the podcast is Ham Radio Workbench. Put those workbenches to use. Build this thing. One thing I will say, Dean will know what I'm talking about here. Build it the way we designed it. Don't say, I'm going to build it, but I think I'm going to use something else. I think I'm going to change the oscillator. I think I'm going to change the audio amplifier. I think I'm going to change this, that, the other thing. And the next thing you know, you're building something that's not like what we built, right, Dean?
Exactly. And why didn't you use an LM386, Bill? And you know, you don't need that oscillator. You can just use an Arduino.
Why don't we do that? And so, yeah. So the next thing you know, whoever's talking to you has come up with something else that doesn't work. And they're looking at it thinking, it doesn't work. And it's all because that Dean guy, he gave me a bad design.
His design doesn't work.
So listen, guys,
sucks.
just do this. Build it. Build the TJDC RX. There's a complete description of it on hackaday.io. We could send you all the files, everything else, everything you need to build this thing. And when you do this, you will have joined the elite ranks of those ham radio operators who have actually built a receiver and a transmitter, which I think is limited to probably 1%, maybe. What percentage of hams do you think have ever done that, Pete?
Less than 1%. Less than 1%. Yeah.
You will have done it. And not only that, you will be able to put the rigs that you built to use. Thomas is deeply into POTA and CW. As a matter of fact, on the Ham Radio Workbench podcast, when I made a few mildly disparaging comments about CW, Thomas was joking that a tear was running down his eye because he liked it so much because he's a POTA guy. You can take this receiver that you build and then pair it up with like a 10-minute transmitter that our friend Walter, KA4KXX, down there in Orlando, points out. And you could pair it up, and then you could actually take it and use it for POTA. You could take it out to the field and make a few of those POTA.
We used the 10-minute transmitter to test the direct conversion receiver at the high school.
That's it. We used it there. And I actually took the 10-minute receiver with the 10-minute transmitter with the TJDCRX and actually made a contact with it. I contacted somebody in North Carolina, a home brewer in North Carolina, and actually used it on the air, both the receiver and the 10-minute transmitter. So you guys, it can be done. So I really encourage Ham Radio Workbench, take up the challenge that is being sent to you by your brother podcasters here, SolderSmoke.
We're entering a new era of ham radio podcast. We're going to borrow from the Silicon Valley folks. We're going to call it co-opetition. Co-opetition. We're cooperating and we're competing.
Wow,
so,
I didn't even know about that. See, this is the best thing about having a Silicon Valley software guy here. Co-opetition. All right, this is an example of co-opetition. You guys, we hope you'll pick up the cudgel and build these things. It could be a great subject for future ham radio workbenches. You could talk about it. You could badmouth me and Dean for horrible designs and why didn't we provide more information and the parts, where they get the parts, blah, 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 all that kind of stuff.
You know, that audio amplifier doesn't have a lot of volume out, Bill.
The speaker's really tiny too. It's a tiny little speaker. These are the problems. But once you get it built, once you get it done, then you're free to make improvements. Right? But build it first. Build it the way we intended it to be built. Don't build something else. A lot of guys say, yeah, I'm going to build that receiver, but I'm going to do this, that, the other thing. And you're thinking, oh, so you're going to build something else, right? No, we don't want that. No, that's not what the challenge is. All right. So we hope that our friends over at Ham Radio Workbench will take up the challenge. Hey, as long as we're still in the opening segment, let me just point out an anniversary is approaching. I checked this the other day. In August 2025, we will mark 20 years of the SolderSmoke podcast. This has all got started back in London back in 2005. Now we're at 2025, so 20 years. And it all started when I was telling Elisa how it started. I started noticing on the bus in London that people were riding around with these white things in their ears, and I really didn't even know what they were. And then I found out later that they were iPods. People were using iPods, And there was an article in the New Scientist magazine called Audio Killed the Radio Star or something like that, or Podcast Killed the Radio Star. That was my introduction. I told Mike, KL7R, about it. He was up in Juneau, Alaska. And without even telling me, the next time we spoke on Echolink. The next time we spoke, he hit the record button. That became SolderSmoke podcast number 1.
Wow.
I also checked, and we have already passed 10 years of Julianismo. 10 years of Pete Juliano with the podcast. His first podcast was on May 26, 2013. So 10 years. Pete, this has been the best times of the podcast, and thank you very much for joining us.
You know, it's going to be 100 podcasts on 263.
Really?
260, because I joined on
263.
163, so 263 will be 100.
100. We got to mark that. We got to do that somehow.
And I'm coming up on 1 year.
All right. Time flies when you're having fun.
Yeah.
All right. Now we like to throw out questions that the group can respond. And I was thinking about this as I struggled with my latest single sideband transceiver here. Pete has built many single sideband transceivers. Dean has broken new ground with single sideband transceivers and even digitized SDR hybrid analog BitX transceivers. We have built a lot of SSB transceivers here. Frank Harris, K0IYE, calls homebrewing for sideband the Nobel Prize for ham radio, right? So it's I think recognized that this is a difficult thing to do. It's not easy. And I was thinking, one of our, I guess, a guy that we read a lot is Doug DeMaw. But when I think about Doug DeMaw's writing and his books, I can't think of a single SSB transceiver that Doug DeMaw designed or built. Now, if you read Solid State Design for the Radio Amateur, of course, there's a lot in there, and he was a co-author of SSDRA. So in that sense, yeah. But he also put out a lot of books and a lot of articles himself, but I can't think of any. So I may be just missing something. So if anybody knows of an SSB transceiver that Doug built and built himself, please let us know. Pete and I were talking about this before. Doug was very much of a CW guy. So a lot of his rigs were CW rigs. He's also the one responsible for me getting into homebrew phone with double sideband, because he wrote this article for CQ magazine called Getting Started in Phone with Double Sideband. And I did. And I was a double sideband guy for a long time before I became a single sideband guy. But anyway, I just wonder about this. If anybody knows about what happened, whether Doug has actually built any SSB transceivers.
Hey, Bill, please. I just did a web search, DeMaw SSB transceiver. And the first article that comes out is a Hackaday article talking about a Pete Juliano transceiver. And the second article that comes up is a SolderSmoke blog.
I know. See, this is what I'm talking about. This is why it's shocking, but it may be true. We'll find out. If anybody knows, send us the links, point to the article, something. Let us know. Did Doug do this? Now he got it wrong on sideband inversion a lot, which makes me kind of suspect maybe not. If you're getting the sideband inversion thing wrong, well, I don't know. It makes it hard to build the SSB transceivers. But anyway, we'll find out. So please send us your responses on that. We're going to talk about benches now. We're going to move to the bench portion of our show. Pete, you're up first. Man, Pete, this is really cool. You've been doing some hybrid rig construction. You've been building some hybrid rigs. Tell us about this, Pete.
Yeah, well, this is something where it's an expedient because of my time limitations. About 2 years ago, I started work on a hybrid SSB transceiver, and I'll define that here in a second. And I got the receiver part working, and I never got to the transmitter part. So, given my limited time here about a month ago, I said, I ought to finish the transmitter part. At least I'll have a complete transceiver. So let's start first with a definition of a hybrid transceiver. Early on, the transceivers that were on the market, commercial and even homebrew, were all vacuum tube. They had LC VFOs in them, and it was all all vacuum tubes. And then the advent of the transistor, as more RF type transistors were available, the manufacturers shifted to building all the lower level stages with solid state, but they still didn't have any high power RF devices. So if you had a FT101, there's an example of a hybrid transceiver. Actually, the first hybrid transceiver was the SBE33 along about 1963, where it had all germanium transistors in the lower level stages and had three tubes. So this is how you got 50, 60 watts PEP in a nice little package. And so when you talk about hybrid transceivers, you typically think about the template that existed in the 60s and early 70s, solid state in the lower level stages, vacuum tubes in the RF part. So, of course, Pete being Pete, I decided to reverse that. So the lower level stages are all vacuum tubes, and the RF part is transistors. So it's a hybrid, but it's it's a hybrid in reverse. So let me describe the rig a little bit. It's got nine tubes in the lower level stages and three transistors. And the nine tubes are pretty standard common fare that you'd see in the tube transmitters of the 50s, 60s, and 70s, 12AU7, 12AX7, a couple of 12BA6s, a 12BZ6, 6BE6, and we even have a 6JH8. Now, many of the tube type transceivers that were built initially used a 7360, which was a special tube from RCA. And boy, today those tubes are really expensive. A new in box one fetches maybe 60 to 70, $80.
Wow.
So you don't want to mess with those. But a variant of that tube, which doesn't quite have the full spectrum of capabilities of 7360, is 6JH8. You get one for $10. So that's what's in the rig here. So anyway, I had the rig working on receive here about 2 years ago, and as a matter of fact, it had a really nice ILI 9341 display, this really big color TFT, and the front panel there. And boy, you tune that thing, you can see it. So when I started working adding the transmitter part, I found this with the receiver. You hit the push to talk, and all of a sudden the display would disappear. It was subject to RF transients. So I said, screw that. So I just rewrote the code and put a 16 by 2 LCD in there. So it really works well. And there are a couple of things that I found as a result of building this, and it's on 40 meters right now. First of, the RF part was three simple transistors. One is 2N2222, which is a pre-driver. A 2N3053 is the driver stage in IR 510. And I want to talk a bit about the 2N3053. This is in the 70s. I built a few solid state CW transmitters for 40 meters, and it had the 2N3053 in it. You could get quite a bit of power out of a 2N3053. And so when I came to the time to add the driver stage, my bin was empty for the 2N2219s, which has been a standard with me for a long time. So I said, well, I got some 2N3053s. I popped that in there and it works really well. And let me give you just a heads up here. It has a continuous collector current of 700 milliamps. And it has a F sub T of 100 megahertz. So if you're going to try to put this on 2 meters, forget that. But if you're doing something at HF, this is a great transistor. And the power dissipation for the transistor is 5 watts. It actually has better power dissipation and current capability than the 2N2219, but the 2N2219 is good for 250 megahertz. So it's a little short on that side, but for HF, it'd be really good. Here's the kicker. A unit price, one piece is $1.09, and if you buy 10, they're 89 cents a piece. So, and you can get those at Jameco Electronics. This is not stuff you get off of Amazon that's already dead. And compare that to the 2N2219A. You can also get that at Jameco. Single lot price is $1.49, and if you buy 10 pieces, it's $12.90. So you could actually buy about 15 transistors for the price of what normally pay for 10. So pretty good deal. 23053, and it works really well. I got 13 ohms in the emitter, bypass with 100 nanofarad and a big heat sink, but it can take a continuous current of 700 milliamps, so that's pretty good. So Class A, Class A on the 2N3053 is a realization to be a good device. So I have a bunch of those and it really works well. A couple of innovations, actually a result of solving a problem. Uh, Loosely, the nine tubes that are used in this are based on a Swan single band units. So I should tell you that the base plate for the unit, and you can see this on my blog, not blog, but my website, n6qw.com. The base plate is 4.5 inches by 6 inches. I got 9 tubes in there. I actually started work on a transceiver back in the early 70s, and this was the base plate. And I got it all built, and it didn't work too well. And so I removed all the components, but somehow kept the base plate. So this transceiver that's on my bench today started 50 years ago with the base plate. So we got a little soul,
A lot of
yeah,
soul in the machine.
soul in the machine, yeah. So anyway, everything's on there, and but you run into a problem because the transmitted signal, the transmit mixer is a 12BE6. So now you have this issue of how do I couple from a 12BE6 to the rest of the solid state circuitry? And so I came up with in the Swan circuitry, they have a couple of coils to, single stage tune coil that is resonated whenever on the transmit frequency. So I said, well, I don't want to put any tune controls in there, no tune. So I don't want to have anything I want to adjust. So I came up with the idea of using a RF choke in the plate lead and coupling off that RF choke. And the RF choke I made using an FT8243 core. FT8243. This thing is
Big.
0.8 of an inch. 8243. If you wind 73 turns on the FT8243, it's 2.5 millihenries. So if you're building any old gear that you need a 2.5 millihenry choke, these things cost an arm and a leg if you try to buy one, old stock. But you can make a 2.5 millihenry choke, 73 turns. That's all it takes. And so I coupled 2 turns on the output. And then I ran that through a bandpass filter, and it works really well. Now, this was the first go at this. I probably want to do something like putting maybe 100 turns on there because it's a better match to the plate resistance of the 12BE6. But right now with 73 turns, it's working just fine. So then into the bandpass filter, which you got to make the transition from the plate resistance down to 50 ohms for the BPF, and then the BPF goes into the solid state stages. That has worked really well. And it solved the problem of how do you couple out of this vacuum tube into the solid state circuitry, because one is a high impedance, the other is a low impedance. You have to have that transition. So that's worked really, really well. And then the following the bandpass filter off the 12BE6 goes into the 2N2222 and then the 2N3053 and the IR510. And believe it or not, on 40 meters, I can hit about 55 to 60 volts peak to peak. And if you do the calculation, you're hitting better than 6 watts on the IR510. And the scope pattern looks really good. It's, you just a current. And that's the other thing too, is I found that setting the bias points for about somewhere in the range of 150 to 200 milliamps on the IR510 was just about the right value. It gives you the 6 watts, 7 watts output, and yet at the same time, it's very linear, and you really want to pay attention to how you bias that in terms of IMD. So it works really well. The other thing that's kind of interesting is I didn't realize this, but most of the guys here use the SDR receiver up in Half Moon Bay. They don't use the station receiver anymore. They just plug into the Half Moon Bay. So I said, okay, this is like the reverse beacon network. So I said, okay, I wonder if I can be heard almost 300 miles away up in Half Moon Bay. And sure enough, there I am, and I'm hitting S5, S7 with my little 6 watts into a delta loop. So it's kind of cool to be able to hear what you sound like and also to see what that signal level is. So that gives you a pretty good feel. I've worked 8 states so far with this rig, and the one that shocked me and shocked the guy at the other end, the guy's calling CQ POTA in Ohio. So I gave him a call on 40 meters, and he says, "Yeah, you're 5'7", 5'8". I said, "That's pretty good. I'm only running 6 watts." And the guy said, "You got to be kidding me." I said, "No." So anyway, it's kind of interesting to see what you can do without running a lot of power. But I think the thing that's important here as well is cost. Um, Vacuum tubes used to be relatively cheap. As everything moved to solid state devices, vacuum tubes were relatively cheap. Ain't no more. I mean, a 12BE6, which was a standard meat and potato tube frequency mixer, they used them in, I think the All American 5 had a 12BE6 or something like that. But they used to get those for $4 or $5. They want $12 for those right now. I mean, I was only able to build this because I got this box of tubes. I've been working on a lot of radios for a long time. So you have all these tubes that I mentioned. They're in the junk box because I used them on other radios. But I mean, if you went out and bought all the tubes today, man, you'd look and say I can build a solid state version of this for a lot cheaper. So I mean, it's just that I had the tubes, I had the base plate, and it's something I always wanted to do. Now, it really makes it nice having the Arduino and the SI 5351 because no one tells me I'm 40 hertz low. No one tells me that. But there is a curious thing, and it occurred more than once, and I just gave me pause. One of the contacts I made, I explained to the guy that I was running a homebrew rig, and as a matter of fact, I have it on my QRZ.com page. So the first picture that pops up is a picture of this rig. And the guy says, "It really sounds good." He said, "But I can tell it's old technology." So I didn't think anything about that. And then it happened again with a different station. He says, "Yeah, it sounds really good." He says, "But it's good for old technology." So I said, "Well, why in the world are they telling? How can they tell me it's old technology?" Then the light bulb went on. The filter is zero point 0.4 kilohertz. They're listening to me on an SD radio, and they're looking at the spectrum. They can see that the signal is not 3 kilohertz wide, but it's 2.4. So that's how they know it's an older technology radio. It's just something that the audio tells them is a dead giveaway. Nothing wrong with it. It's just now the standard has become if you're not 3 kilohertz wide, it's not a good sounding signal. But anyway, it's been a lot of fun. There's still a few things I want to do with the radio. Of all things that don't work, is something that I was in there that I thought would really be a nifty idea. Swan initially did not have this in their monoband radios, and then they added it. As a matter of fact, I got a Swan radio one time that this tube, it's a tone oscillator, was stuffed underneath the chassis. They just screwed a bracket on, and you open up the bottom of the chassis, and you're expecting to see, resistors and capacitors and inductors, and here's this tube, horizontal. So, I mean, it was something they added as a tone oscillator. I could not get that to work. Supposedly, if you hit the button, you ground the cathode, you're supposed to generate a tone that goes into the mic circuit, and the tube is not bad. So I'm still scratching my head saying, why doesn't, of all the things, why does not the tone oscillator work? Now, one thing I am able to do for tune-up is unbalance the carrier, and I can see that the carrier suppression is 40 dB. So in other words, you can balance it, and then you unbalance it, and you see what the difference is between the balanced and unbalanced, and the difference is 40. Now, many of these rigs actually had a better carrier balance, like 50 dB. Is not unusual to see with the specs of these rigs. So I'm not sure how that is. Now, that could be because I had to fabricate the balance modulator coil that serves the purpose. This balance modulator coil, one half of it takes the output of the 6JH8, the balance modulator, put it through the filter. The other half takes the input from the receiver mixers that feeds it in the filter. So it's a common element. So it may be that homebrew constructed transformer, with if I paid a little more attention to it and constructed a little bit different, I would get a little bit of suppression. So there may be some spillover. But anyway, I thought 40 dB was pretty good for carrier suppression. But it's been a lot of fun. And it's interesting because 40 meters is nothing but nets, and they're all on standard frequencies. So don't go 40 hertz low or 40 hertz high, because they're going to let you know and let you know real quick you're 40 hertz low. But it's
You
good
got
to
you
see.
got to stay off that channelized band, man. Every one
Yeah.
kilohertz, click, 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 digital
Uh,
display.
uh,
Hey, I got a question for you, just an observation. So you talked about your transformer. You talked about having 78 turns and then two
73.
turns, 73 and two turns. Okay, so you're doing an impedance matching, right?
Yes.
Because the
Yes.
impedance ratio is the turns ratio squared.
Yes.
So it's like 35. So it's like 1500
Yes.
to one impedance ratio. Okay,
Yes.
got it.
Actually you do that transform. It's 66K on the tube, and it's 50 ohms on the other side.
Yeah, got it.
Pretty cool.
Well, that's one of the things that our makers group, when we're building transformers, they struggle with that concept a little bit about how those transformers actually work.
Yeah, but the FT8243, actually I tripped over that when I was doing a presentation with the GQRP club on a vacuum tube transmitters. I needed a choke. And I'm saying I'm not paying $50 for a choke that had been on from radio, whose specs are kind of questionable. So I said I needed a core, and the 43 core is too small, and the 50 core is too small to get enough turns in there to get the inductance. So then you don't hear too much about an 8243. So I looked at it and I said, man, this is pretty good. And they're not that expensive. I got them from Diz, is where I got the cores. And I figured out all you need is 73 turns for 2.5 millihenry, and I got that in a vacuum tube transformer. That was the first time I did it, so I said, this is okay. So anyway, that's the story, Bill. Out of this is impedance matching out of tubes into transistors, and the 3053. That's certainly a good device to look at, and they're worth it. Now they won't work on 2 meters. So someone who buys these says, "Oh, you can't get it to work on a 2 meter." It's not good for that, but it's certainly good at HF.
Pete,
That's it.
I looked at the pictures that you posted of it, and just the picture of the upside down base plate showing the circuitry and how you had wired it was inspirational. It brought me back to what the inside of my HT37 looks like, or the upside down, or under the chassis, even on the Drake 2B. A lot of point to point, a lot of it's just wonderful the way they used to build radios back in the day.
But here's the problem. Fat fingers. The ladies who built those had slim, agile fingers. When you got fat fingers like this, to keep that in mind, that upside down view, that's 4.5 by 6 inches.
It's small. It's a tiny thing. Yeah, yeah, yeah. And you've got a picture of the rig behind you, right? That's what you have right there,
Yeah,
right? Because I could
yeah,
see where you used to have the 4.5 inch display. Now you
yeah,
have the 16 by 2.
yeah,
And you could tell that the size of the whole thing based on the size of the knobs.
yeah,
Pretty cool, Pete. Thanks very
yeah,
much.
yeah, you bet.
Hey, Dean. Dean has made some big progress, big progress. Tell
Oh,
us
big
what's
prog.
going on. Tell us what's going on at your two locations, two
So
places.
from kind of the very cool rig that Pete just described, I've been at the other end of the RF line here, working on antennas. First up, inspired by N2CQR's success with his K4KIO hex beam. I bought the hex beam and over several weeks built it, and I've never had a steerable antenna. I've only ever had a wire antenna
But Dean,
before.
just watch out for the cockatoos, okay? I mean, you got
We
to
have
watch.
no cockatoos. We have
All
no
right.
cockatoos, but um, the the antenna itself is fairly easy to build. The kit that K4KO sends is very complete. But there's a number of things that, as a newcomer to this, I had to learn, which is that, okay, you can't just buy an antenna and put it up. You have to have some way to like mount it. So I had to get a tripod. Got that from Roan. You got a tripod and the antenna, but you got to have some way to turn the thing from your shack. So you need this thing called a rotor. And I'd known these things existed, but I'd never really seen one before. I never built one. So I bought the Yaesu rotor, and, gradually the parts start showing up, and I get the rotor and I get the mast and I get the antenna, and there's no way to like put them all together. So I had to get a clamp for the rotor from Yaesu that clamps to the mast of the tripod so that I could put anyway, so I got it all built in the backyard, and got the rotor fired up, and man, it's cool. You turn that dial and the thing spins, and you can tell and as soon as I had it up just on the deck in the backyard, one of the first contacts I made was with Malaysia. I have never had a contact with Malaysia before, ever. Right. And then the issue is like, all right, how do I get it up off the deck? Because Sandy, my wife, was not too happy with this giant antenna out on our back deck, and I'm not climbing any roofs. So
Important point.
I got and I don't really have a good place in the back without trees to put up, and I don't want to put a big mast in the ground and all of that, but I did want to put it on the roof. So I got a local handyman that I've worked with for years, and he was great. He did all the roof work, and by using a handyman who actually knows what he's doing, I actually got a very solid installation. So what he did is he mounted the tripod on the peak of the roof, so two legs on one side, one on the other, and then he went into the attic, and between the rafters, he lag screwed 2x6s, and then he lag screwed the feet of the tripod into the 2x6s. So this thing is going nowhere. It is really solid. And the K4 KIO has a very low wind load. And but I will say, that my wife took one look at it and she said, I didn't know what I expected it to look like, but I didn't expect it to look like that.
So I have a picture. I have a picture of Dean's antenna. And I think it is a thing of beauty. I'm sure Pete will agree.
All the radio guys agree. We got a ham down the street who's got a couple of towers in the back. I said, "Hey, I don't have towers in the back. I just got it. I just got it up on the house." And he came over and was admiring the thing of beauty.
It's a beautiful thing. It is, and it's an acquired taste. I'm sure Sandy will come around.
Well, my view on all of this is like the people that argue against the look of solar panels on their roofs. Who looks at roofs when you drive around a neighborhood or walk around a neighborhood? You might see it once, and then it fades into the background. You never see it again. At least that's what I'm telling myself.
Just tell yourself, and tell Sandy that too. Yes, sis.
Now, so you might hear Walter in the background. I've been feeding him treats as we go, and he's like, "You stopped feeding me when you started talking." So
he's opposed to the SolderSmoke podcast. I have Guapo locked up in the front room, by the way.
Walter's a beagle, and he's a very happy dog, but he's like, he likes attention. All right. So the other thing is, I have a second. So the beauty of this is, I live in a neighborhood that doesn't have an active HOA, and I can put stuff on the roof and nobody's going to complain. They might complain, but they can't do anything about it anyway. So the other end of the spectrum is we have a townhome on the eastern shore of Maryland in the little town of St. Michael's, and it is a heavily HOA'd community. And we're in a middle unit of a 4-unit building, and there is no possibility of an exterior antenna there, none whatsoever. I have put up antennas like for a few hours, on a pop-up mast in the yard, a wire antenna, an end-fed half-wave. And even then, people wander around and look at me, kind of cross-eyed and trying to wonder what I'm actually doing. So I want to put a attic antenna up because I've got a fair-size attic. And so I've settled on putting up a random wire end-fed antenna. And the first thing I learned is that random wire doesn't mean random length. It means non-resonant on any frequency that you want to use or any of the harmonics of the frequencies. It's actually a very selected length and not random at all. So why they call it a random length, I don't know, but it's not random. So turns out that 35.5 feet is a good length if you want to run from, say, 40 meters to 10. No resonance on any of the ham frequencies or any of the harmonics of those ham frequencies. But this kind of antenna requires you can feed it direct to a tuner, but then you'll bring RF into your shack. So the typical way people are using them now is you build a 9-to-1 unbalanced transformer, and that's where one of those big toroids comes in, Pete, because you wind it on there. So you're doing a 9-to-1 wind, and I used one of those for that, and so I built the transformer, and then I used another one of those big toroids, and I made an RF choke just by winding about 8 turns of coax through the choke. So antenna comes into the unon, out of the unon comes coax, goes through an 8 or 9 turn choke, and then that goes to a tuner. Well, I don't have an extra tuner, so my next job is, all right, what kind of tuner am I going to use for this? Now, I could do the thing and use the credit card and go buy an LDG auto tuner and be done with it. But I thought, no, I am a home brewer and I want to learn to build an antenna tuner because I never built one of those before.
That's the spirit, Dean. That's the spirit.
So I did all the looking at Z match and T match and pi match. And anyway, I settled on a T match antenna tuner, and a T match antenna tuner is 2 variable capacitors in series with the transmission line, and an inductor to ground that's a variable inductor. And I have a Palstar tuner that my dad gave me, a big boxy, which is exactly the same architecture, and it's the skinny on the T match as opposed to the other architectures of tuners is it'll match a really broad range. It can tune anything, and it's not as sensitive as some of the others, so it's not as hard to tune on all the bands. Now the trick is if you're going to run more than QRP, you need some fairly hefty capacitors and a fairly hefty inductor. Well, the caps I got out of our Radio Club's junk box, one of them is 500 picofarad, and others a 368 picofarad, and they're big, chunky guys with a lot of space between the plates. The coil, I picked one of those up out of the junk box. It was about 12 or 14 inches long, and it's like way too big. So I decided I wanted to wind my own coil. So here was another thing, like, all right, how do I wind like a 2-inch coil and make it, uniform and have decent spacing? So I tried winding it by hand. It didn't do any good. I got a piece of 2-inch PVC, and I tried winding it on there, and I could wind it, but it was a mess. But I found that I could get these they call them grommet strips, and it's a piece of nylon that basically has little teeth, and the teeth are perfectly spaced for winding that coil. So I glued 4 of them onto the 4 sides of the 2-inch PVC, and I got a perfectly wound, beautiful coil. And then I can put some taps along the way. It's not going to be a roller inductor like my Palstar, but it'll be a tapped inductor, so I can switch to various inductances for the tuning. Well, I got it built this week, at least up on a piece of plywood, and I got it all wired up. And sure enough, it tunes just like it is supposed to. I bought a little SWR meter from Astatic, Astatic, the D104 company. Turns out that the Astatic company is no longer the Astatic company. They're owned by a company called Road Pro that does a lot of CB stuff, and they've got a very inexpensive, about a $20 SWR meter.
And you get what you pay for.
And you get a $20 SWR. Well, it actually, once I kind of figured out how to use it, you can't just like put a signal through it and measure SWR. You have to go through like a calibration step each time you use it. So you have to get the meter zeroed, and and every time you change bands, you have to change it. And it's tuned for 11 meters, which means it doesn't read power right on our HF frequencies. I think I can adjust it. There's a couple of trimmers inside. I'm going to take a look at that. But anyway, for an SWR measurement, which is all relative, it works fine, and I got it tested and compared. But here's another thing that another first for KK4DAS is I got my first RF burn, Pete. So
it turns purple.
Yeah, all of the exposed components on that piece of plywood are hot when you're transmitting. And I was turning the dial on one of those caps, and my little pinky just hit the frame of the cap, and I lit up like a Christmas tree. So, there we go. So this is why you want that in a shielded container, and you want to use decouplers on the shafts of the capacitors. You don't want any of that hot RF getting anywhere near your fingers. I can tell you that. So there you go. So I feel like a real home brewer now. I've had an RF burn. I learned a lesson. It was really good. So that's going to go
Great
up in the
news.
attic. That's going to go up in the attic at St. Michael's, I hooked it again. I just tossed it up in the yard, and I made a couple of contacts. One in Florida, one up in New York, and then I talked to the country of Georgia in Eastern Europe. So I know that the NFED is working, and I know I can get it tuned. So I wanted to mention one other thing before I kind of move on. It's not something I have built yet, but our club, the Vienna Wireless Society, is going to embark on a balloon project early in the year. And we're going to build one of these Raspberry Pi Pico driven whisper transmitters and launch it on a balloon. We've got a guy in the club, Jake, N0LX, November 0 Lima X-ray, who has built a couple of these now. The last one of his, he built and went around the world 5 times and was trackable on some internet. So there's a whole community of people that launch these balloons and they track them, and then they have their trackers set up to report over the internet so you can see them. There's a website called Traquito, like taquito, but with an R, Traquito. And with Traquito, you can actually get on and look at the track of these things. I'm just looking at the one he launched a while ago. It's halfway around its second circumnavigation of the Earth. It's just outside of Portugal, just outside of Lisbon right now.
And Dean, these are using just the small little metallized birthday balloons that you get down at the local supermarket, right?
Yeah, or you can get you can get a Mylar balloon that's like used for a weather balloon or for that kind of thing. So and then it uses a Raspberry Pi Pico, and a long thin wire that you drape behind it. I think they're using an SI5351 to generate the whisper signal. But it's very, very cool. I mean, we were looking at the track of the thing, and with some of the stats that you can get, you can see what the weather is at the heights, and it goes pretty high. It's like 20,000-30,000 feet in some places. One thing he noticed was that it went over the country of Israel, and suddenly its GPS tracking went crazy. It thought it was over Jordan. So his speculation is that the Israelis are GPS spoofing to, send things, nasty things coming their way that might be GPS guided other places. So he said, but as soon as it left Israeli airspace, it came back and it was right where it was supposed to be again. So very interesting.
Very cool. I've been thinking about doing something similar from the Dominican Republic, and I actually started toying around with this. And I was looking at where the prevailing winds were. We're on the eastern tip of the island of Hispaniola, and I was really hoping that the winds would take it out over the Atlantic, but they won't. The prevailing winds are coming east to west. So if I launched a balloon from the roof, it would fly over the Dominican Republic, fly over Haiti, and then into the Caribbean, probably down towards Panama, which would be fun too. So I might do it. I might join you guys. I'll be down south at that point, but I might be building one down there also to launch off the roof.
Well, it's really cool. Traquito, also, there's a Traquito kit that has the little PCB all set up for you. So we may end up, because you need everything to be, as you can imagine, really, really lightweight and small in order to launch it in a balloon that's going to stay up. The winds get surprisingly high up at those altitudes, though. He was saying that they've measured 250 miles an hour at some time. So that balloon is really moving along.
Wow. Pete, you were going to say something.
Yeah. Hey, Dean, I wanted to give you a couple of comments on the antenna tuner. So first of one technique that has been used in the past, of course, the idea with those Teflon strips is really good, and I knew immediately when you said it, the light bulb went on. But what the guys used to do is take some plastic plates and drill holes in it, and then they'd feed the wires through the holes, and they glue two pieces like in an X form with the holes, so then you can feed the coil through the holes. And the other thing is that I've used, if you want to run a little more power, the capacitors will certainly handle it because I saw the size of those as pretty good from a power standpoint, but that air ducts coil may not handle the power level. But something they use is 1/8 inch copper tubing. 1/8 inch copper tubing, and boy, you can run a couple kilowatts through that because of the skin effect that travels on the skin of the tubing. And then what you can get is some of these brass strips, the hobby strips, and you put them around and just solder them together. And then you can clip lead to the brass strips. So that's another thing you do. And then if you want the Nate Plus Ultra because you're going to have your antenna, you might want to put the tuner right at the antenna. And when you're ready for that, I have a stepper motor program that'll tune the capacitors. So you can sit there with the console and tune the stepper motors from your desk, and you don't have to worry about burning your hands. It's all done over an eight wire cable, and you got it all set to go. So anyway, lots of things, lots of fun things you can do with that antenna tuner.
I have a
Well,
similar
one of the
tuner
guys
out,
that we
out in
we
the
have
carport, and I have to step outside in the heat or the cold. So if the weather's bad, I don't change bands as often.
and you're never outside to touch it while you're transmitting. So
Yeah,
I know, that's
yeah,
it.
one of the guys in the club, we have this club lunch on Tuesdays, and he says to me, "Well, why don't you just get an LDG auto tuner and put it right up at the antenna?" And my response was, "Because I don't want that. I want to build my own antenna tuner."
That's the spirit, Dean. That's it. Tell them. All right, guys. I guess it's time for the shameless commerce division, right?
Yes.
All right. So, we've been talking about how we've been concerned about a decline in readership and viewership, but I think there's something that you, as the SolderSmoke audience, can do about this. Please put links to the blog and the podcast on your blog or on your podcast, because a lot of the search engines take a look and see how many people are linking to the particular site of interest. So please put links to the SolderSmoke blog and the SolderSmoke podcast. I do that with a lot of the on SolderSmoke. I have links to a lot of different pages on there. So I'm practicing what I'm preaching here, and I wish that our listeners would do more of the same, because that'll help us out. Also, please think about becoming a Patreon supporter. I have Patreon links on the SolderSmoke blogspot.com page. And I do occasionally, or pretty regularly recently, put content up there that's not being put out on the main blog. So you as a Patreon supporter will be getting some special content there. I encourage people to do that. Let's see, what else? Oh yeah, mostly DIY RF. Todd out there in Portland, K7TFC. Please make use of the great boards that he produces there. He produces some really good PC boards. As a matter of fact, I used 4 of his boards for the termination insensitive amplifiers that I put in the new transceiver that I built. I'll talk about that in a minute. But he has many great boards out there, many great parts and kits. Take a look at that. Please buy your clip leads from Parts Candy. Carlos, and I've got links up on the right-hand column of the SolderSmoke blogspot.com page, and also on the latest post about Matthias and the fake wires from China that do not affect the clip leads built by our friend Carlos. Parts Candy, that's one word, partscandy.com. Check it out. And then finally, make use of the Amazon link on the SolderSmoke page. If you're buying something, especially if you're buying something big and expensive, like a Lamborghini or a top of the line Spectrum analyzer, yeah, by all means, buy it from Amazon through that link on the SolderSmoke page, and we'll get a chunk of
a Roan tripod for your hex beam,
a Roan tripod, anything like that. Thank you, Dean. And we'll get a little bit of money from that. So anyway, thanks very much for that. And that concludes the Shameless Commerce division for this week. I want to talk a little bit about something that I have on my bench, and I have it actually right here. For those of you who are looking at it in video can see it, but if not, I'll describe it. I built yet another SSB transceiver because when I was down in the Dominican Republic, I kind of missed having a completely homebrew 20 meter rig, and the 20 meters is such a great band, and I missed having my Mythbuster. So I built when I was back here, back in, when was it? August 2021, in the middle of the pandemic. I built this thing called the Mythbuster, and it has a 9 megahertz VFO that I got out of a Yaesu FT101 because Pete recommended that I buy one. At the time, we thought that the VFO would come just with the reduction drive and the anti-backlash gearing. But we discovered that when the sellers sent this part to us, it included all of the guts for the VFO. So what the heck? There's a 9 megahertz VFO in there, and we put it to use, and I've used it in these rigs. The original Mythbuster covered both 75 and 20, but I never used the 75 meter portion, and I'll make less use of it down in the Dominican Republic because I just don't have room for a 75 meter antenna. Plus, it's really noisy down there. I'm never going to get on 75. So I built this one on just for 20 meters, but it uses the same kind of crystal filter at 5.2 megahertz and the VFO from the Yaesu FT101 at 9 megahertz. I have had fantastic good luck with this thing. Everybody says the receiver sounds really good. Let me see if I could turn it on here. Let you guys listen to something because it's that time of the day. Hold on.
Get down at one end of the runway, and you have this winch.
Let me give you a little bit of CW here. Hold on. There's FT8. Anyway,
Boy, that's a
it's
real knob on there, Bill. That's a great knob that you got on
a
there.
great knob, and I was telling Pete before that I'm torn because I might put a digital PLJ, just one of these little 6-digit LED readouts in there to give me a more accurate frequency readout. It'd be simple to do, but the receiver sounds so good. I'm almost kind of averse to putting a noise source in there. So I'll work it out so that I can easily put the SIGGEN in there if I want it. If not, I'll just make use of the dial that comes with the Yaesu FT101. I might flip it over and make a little circular readout for the 20 meter band. But I've had
Bill, the rig sounds great. I mean, I've heard long videos from it, audios from you, and it's working really great. And I think it's amazing, as we build more of these things, I talked about this, we get faster at doing this thing and we make fewer mistakes, but we still make a mistake or two along the way. You might want to talk about your amplifier tale of woe, because I found that pretty interesting.
Dean makes a good point. We do get faster, but sometimes the speed is our enemy. So I checked on my phone because I take pictures as I go along, and the picture, of course, gives a date timestamp of when the picture was taken. And I know from the iPhone that I began construction on this thing on October 19th. So here we are, November 13th, and I've been on the air with this thing now for a week or so. So it took about 3 weeks to build this thing. But I was going through pretty quickly at using sort of familiar circuits. I've had many people ask me, where's the schematic? I want to build one of these. And I have to go back, and as Pete has done many times, say, well, there's really no schematic. The schematic, it's a collection of stages and a lot of different sources. And we end up with an SSB transceiver. But Dean is right that we do make mistakes, and I made mistakes because one of the things we always tell people to do is build it stage by stage and carefully test each stage before you move on. And there is where I was getting kind of careless. For example, when I got to the RF amplifier stages, it's right out of the BitX40 module, the RF amplifier. There's 3 stages. There's a 2N3904 in the pre-driver. For the driver, I had in the junk box a 2N2218, which is much like the 2N2219 that Pete was talking about. It's basically the same kind of transistor. I just happen to have one, so I popped it in there. And then for the final, instead of the IRF 510, I use an RD06. But other than that, it's the same. And I I tested each stage as I was going along, but I was really just testing to see if a signal was making it through. I wasn't testing for signal levels, which I should have been doing, right? So I built the first stage, boom, signals going through, yep, input, output, yep, move on to the next stage, input, output. And then when I put the whole thing together, I found I was getting about a half a watt out, which from the whole rig, which is not what you're supposed to get. You're supposed to get closer to 5 watts, right? So something was wrong, and this sparked a whole wave of kind of unnecessary troubleshooting that I would have avoided if I had done the kind of proper testing that we always prescribe. So I eventually found the problem. The problem was in the degenerative feedback circuit in the pre-driver. And there's a cap and a coil to ground, a 10 ohm resistor. No, a coil, I'm sorry, a resistor and a cap to ground, a 10 ohm resistor and a 0.1 microfarad capacitor that plays a huge role in setting the gain, the RF gain from this stage. And they were completely open. I mean, the resistor might have been too small. It might have been junky. The cap might have been a Bojack example and might have been kind of junky. But I just went there and replaced it with a decent cap, a 104, 0.1 microfarad cap, and two 4.7 ohm half quarter watt resistors in series to get to about the 10 ohms, that 4.7 ohm resistor, two of them in series to get closer to the 10 ohms, and boom, it was back up at 5 watts. Bob was my uncle. But I ran into a lot of like little problems like that caused by kind of speed. There's the old saying, speed kills, and speed will make you, I think, a little more careless than you should be. Now, on the other hand, I'm doing something that I probably didn't do enough of with previous rigs. You'll see I have the guys who were looking at this on video. I have a little folder that I opened with the paperwork for this rig. And I'm keeping notes on each stage, what happened, why I made the selections, what software I used to design the filter, what software I used to design the amplifier coming out of the VFO, what software I used to design the bandpass filter, the circuitry that I use for the final amplifiers. And so this will help me in the future. One of the problems is, and Pete knows this, when you build many, many SSB transceivers, they all kind of blur together in your mind. And I want to be able to pull out of that folder and say, wait a second, let me think, what did I do with this stage? Why did I build it this way? So I've got some good notes that are going in there.
Hey, Bill,
Yeah.
Tony Fishbowl, our friend Tony,
Yeah.
he shared something with me that I hadn't thought about. He does the same thing, but he puts it on a flash drive, and he puts the flash drive right in the rig.
That's a
So
great
this way,
idea.
so this way, he says the flash drives are so cheap. He says you got everything on the computer. He says you just put it in the flash drive. You want to figure out what you're doing. He says I have it installed right in the radio, and I said, man, that's brilliant.
That's a variation on this. That's a great idea. It's I was talking about this on the on the Ham Radio Workbench. Why do you do this? Why do we do this kind of thing? And I said, well, there's a much higher level of satisfaction when you're able to work the world on a rig that you built yourself, that you kind of forged out of parts that are just laying around the shack. And that's the case with this. I don't think I had to buy a single part here. Everything was just in the junk boxes here in the shack. I got on the air the other day with it. It's on 20 meters. I don't even have it hooked up to the 0.1 kW linear amplifier. So the output of this thing is about 3 watts PEP because I've cranked down the output a little bit. And I get on and I hear Lyle ZS1 UOK down in Cape Town, South Africa, calling CQ. I swing the hex beam around to the southeast and I give him a call. And this little rig here that you're seeing on the bench here, it's still on the bench. It's not even in a box. All the guts are exposed. It busted the pile up, and I had a nice little conversation with Lyle in South Africa. I've worked Europe several times, many stations, many POTA stations in the United States. One guy who, after I told him about the rig, I told him that it was on a pine board, exposed, all the parts still on the workbench. He said, yeah, but you're about 40 hertz low, old man, Okay.
So,
all right, fine.
So I
But
want to reflect a little bit on your conversation about the junk box, because if you're listening to this podcast and you think I want to get started, but I don't have a Yaesu FT101 VFO. And by the way, Bill, since you started acquiring these off of eBay, they're now $85 on eBay.
I
So
blame
I'm
Pete.
not buying. I'm not buying one either.
Pete started it.
But I've been at this now 4 or 5 years. I started with Michigan Mighty Might. Bill sent me the actual crystal in the mail, which I had to pay $1 postage due on because it was too fat to be an envelope. Thank you, the U.S. Postal Service.
Sticklers.
To get the 8 miles from between our two houses. You don't need much to get started. You don't have to have this massive junk box that Pete has and that Bill has, and now I have. I mean, I started with a couple of kits of transistors and resistors and capacitors from Amazon that maybe cost me $30 altogether for the first couple of things that I built. And then for hams, go to the Ham Fest, because there are tables of this stuff basically for free that you can walk away with, and you can pick up just about it, like those 2 big capacitors that I put in my tuner. I got out of the club's junk box because it was from a state, and we had acquired stuff, and they just said, "Come get what you want," and we came and got it. So you don't need to spend a lot of money. You don't need a lot of stuff. You need a soldering iron. You need a good multimeter. Later on, you're going to want to get an oscilloscope. That'll be the first big thing you purchase. But after you do that, you have what you need to build all this kind of stuff that we're talking about.
Yeah, and Pete always says this is a good time to be a home brewer because there's so many sources of parts available. It's actually a lot easier than it was years ago. You'll get guys say, "Oh, I can't go down to the local Radio Shack and buy a 0.1 microfarad capacitor," which is true, but you could go on to eBay or Amazon and have them drop the stuff on your front porch the following day. I mean, it's pretty easy to do. One thing I would advise is anytime you buy parts, buy extra parts. Buy the parts that you're going to use in the rig, but you're probably
never
buy
4.1 microfarad capacitors. Never do that.
Buy 8 at least, because you're going to be using them again. So
buy 100 and it'll cost you $2.
That's right. You start building up a junk box, and then you build up the capacity. But then the other thing is you're building up your own knowledge. As Pete always says, when you know stuff, you can do stuff. And, it becomes easier to get a rig going. I talked a little bit about the struggle I had with this, but there was never any doubt in my mind that I was going to get it working. It was just a matter of, I got to find out why this amplifier is not amplifying enough. Okay, I found it. Yep, there it is. The generative feedback circuit's kaput. Fix that. Boom. Bob is my uncle.
Yeah, there's another thing too. When the guys ask you for a schematic, when you're starting out as a home brewer, as I did just a few years ago, and you look at a schematic, it looks like an undifferentiated mess of stuff that is connected in all kinds of crazy ways, and you have no idea what you're looking at. Eventually, if you do this enough, you'll start to see, oh, that's the audio amplifier, that's the filter, that's the RF amplifier, those are the mixers. The little circuit components become obvious, but at the beginning, it's not so. Yeah. And so there's a guy out on the West Coast who's on this podcast right now that publishes, when he does his projects, he publishes individual schematics for each component. So you got the amplifiers, the RF, and he describes exactly what they are. And that's Pete, right? So the first complex rig I built after the Michigan Mighty Might was Pete's simple SSB. And what it did for me is it allowed me to work in stages because he only gave me one schematic at a time. So I didn't have to think of that whole giant radio all at once. I thought of, now I'm building an audio amplifier. Now I'm building the IF module. Now I'm building the RF. Now I'm doing the switching. And if you take it that way, it's much less daunting than looking at that giant schematic and trying to figure out, where do I start? And the other benefit you get is you've built a module, you've tested it, and you know that module's working. You built another module, test it, you know that working. So when you put them together, they're going to work. You have much less chance of it not working at that point.
Yeah, and I think
there's another, excuse me, Bill, there's another advantage, Dean, and that is if you want to upgrade something, you can just take that module and upgrade that module and without destroying the whole radio. So I mean that's the advantage of the module. You can and then you always have a benchmark of how it performed with the prior module. So there's a real advantage to that from that standpoint.
I think you're right about this, and I think that this is the thinking that that went into our construction of the TJ direct conversion receiver project that we built. That we had the students, we told them, look, there are only 4 stages in this whole thing. These are the 4 stages that Farhan talks about as being the essential stages in any radio. And just do them one at a time. Build the bandpass filter, build the oscillator, build the audio amplifier, build the mixer. You put them all together, you got a direct conversion receiver. So this gets back to the challenge that we have thrown down on the gauntlet we have thrown down for the Ham Radio Workbench thing. Dean is pulling out one of his rigs.
I am. I happen to have it behind me. I lost my earphones here. So here's the 10-meter double sideband rig that I built last year. And if you see Bill's rig in the background and this rig here, they look suspiciously familiar. You see every single board, every single module's on its own board. Everything's kind of wired together. I tested one thing at one stage at a time, and I reused boards that I had pulled off of other rigs. That's the other thing that happens. You build a module, and we all now have boxes of boards that could be rigs someday.
we all have boxes that are marked on the label, boards that could be rigs.
Exactly. So
inspirational stuff. I just say that my construction technique has evolved. I don't go from the board stage to putting it in a box stage that more diligent constructors do. I just build it on the board, get it working, and then build the box up around the board. I found a source for 1/8 inch plywood that I just slap on a front panel. I slap on some side panels, top, maybe a back, and then I'm done. And I don't have to worry about taking a rig that works when it's spread out on the board, but doesn't work when you put it in a metal box, which happens a lot. Anyway, thanks, guys. That's really good. Oh yeah, one other thing I was going to mention, since we're still talking about my bench, I need an amplifier for the Dominican Republic. I need another 0.1 kW amplifier. So I think I'm going to build another CCI amp. Pete has been making some really good recommendations. I think I'm going to go with that. I might build it here. I might just take the kit with me down to the Dominican Republic and build it down there.
Tap the holes.
I know. I
tap the
tapping
holes.
the aluminum. I tapped the aluminum for this rig yesterday. I had to tap the aluminum there for this rig too. So we can work on it that way. I'm getting phone calls here. I'm going to go into an appointment tomorrow, and they're trying to confirm it. But anyway,
I also want to build a 0.1 kilowatt amplifier, but I'm thinking of going a different direction. I'm thinking of doing a whole homebrew thing, 100% homebrew, and I'm going to get a couple of these RD 100 transistors. They're about $50 a piece, so they're not cheap, but it's cheaper than one of the CCI kits, and we'll see. I don't know. It's always a challenge when you start building higher power amplifiers, getting the layout right, and getting the feedback. So
he's shaming me into doing this. He's shaming me. He's pushing me in. I know. It's hard.
I don't know.
It's hard. I feel like such an appliance operator buying a kit, man. Oh God. I was just talking bad about the Ham Radio Workbench guys because they built kits, and here I am talking about buying a kit. Maybe I'll do what you say, Dean. All right, guys. Time for SolderSmoke Mailbag. We've been going on here for a while, but let me get through the mailbag here. We got a real nice email from our friend down in Melbourne, Paul, VK3HN. He talked about the nice sound of the Mythbuster 2 receiver, and he also mentioned a new CW QRP rig from Dave Benson, K1 SWL, which was really nice. He sent us information about that. I got a really nice email from an old friend, Nick, N3FJZ. Nick was the guy who once rescued me from the 40-meter waterfall police. He came on and he had a direct conversion receiver, and he said my rig sounded fine. He sent some very kind words about the support that the SolderSmoke podcast has provided to homebrewers over the years. Thanks very much for that, Rick. We also got a good message from another really, really old friend of the podcast, Chris, KD4PBJ, he sent us a very nice message. Thanks for that, Chris. Kevin from Belgium sent a nice blog post in support of the SolderSmoke effort. John, WB4BTL spotted his old call from 1974 in my novice log. And he had a different call at the time, but he spotted his old call, and I managed to go to the paper logs, take a picture of the logbook, and send it to him. We got a similar message from Dave, KD2E. He spotted his novice call in my novice log. He was WN2TBB. He also spotted an old friend, WN2EHE, was also in my log. So I've taken the essence of my novice license logbook, put it on the soldersmoke.blogspot.com page, and guys are coming across over the years, they're coming across their old novice calls and sending me a note or a comment saying, hey, I see my old call sign in there. So that's pretty cool. I had a nice experience with Mehmet. Mehmet is a guy here in Northern Virginia. He runs a web SDR called NA5B. I think that's Mehmet's call sign. I think at one point he was connected with the club too, Dean. And I had a little bit of a Facebook problem there with a page that Mehmet runs, and he squared it away immediately. So thanks very much for that, Mehmet, and thanks for providing that really useful web SDR that many of us use for testing rigs, like Pete is doing with the Half Moon Bay web SDR. Mike, WN2A, sent us asked some questions about the Yaesu FT101 9 megahertz VFO, which Dean reports is now priced beyond ham radio means. It's all, I blame Pete.
Like the QF1.
What happened to the QF1s? I know. But we answered Mike's question. Mike is a prolific home brewer responsible for the MouseFET transmitters, and it's always great to hear from them. Another guy it's always great to hear from is Phil, W1PJE from MIT. PJE from MIT. And he was writing to us about old broadcast radio shows, and he provided some really nice words of encouragement about the podcast. Another great friend with a lot of experience in the what he would call the Thermotron area, Pete, is Grayson, KJ7UM. He sent nice words of encouragement about the podcast and provided a lot of great background information in support of the construction of hybrid rigs using what he would call not tubes. Grayson says a tube is what you have when the roll of paper towels runs out. That's a tube. The Brits call them valves. Valves are what you have on the outside to turn the water through the hose on. That's a valve. So what we're talking about here are thermotrons. He likes the term thermotrons. Anyway, thanks for writing to us, Grayson. Got another message from Peter, VK3TPM, who has his own blog that's really kind of cool. He writes about the decline of blogs, the decline of blogging, but notes that blogs remain useful repositories. And I think that's a point that we have to keep in mind. You know, whatever we write in the blog might not be immediately useful to somebody, but 5 or 10 years down the road, somebody might come across it and say, hey, wait a second, that solved my problem. That answers my question. This is how I came across Pete first. I found some of Pete's old articles on a blog. I mean, 5 years after he had written them. And that's what led to 10 years of Julianismo here. This is great. The good repositories.
The other thing I find is, for me, it's actually another form of my project notebook.
It is. I find myself all the time. I'll go to Google the problem, and then Google will send me back to my own blog spots. Oh, this is something that you wrote in 2020. Oh, yeah, that's right. Forgot about that. Pete doesn't forget anything, so he doesn't have this problem, but the rest of us. Todd, K7TFC. Todd sent me an additional board. When I was building this rig, I decided to use Todd's little boards for the termination insensitive amplifiers. I joked on the Ham Radio Workbench. They said to me, "What does it mean? What does termination insensitive amplifier? What does termination insensitive mean?" And I said to him, "Termination insensitive means when your girlfriend breaks up with you and you don't care. That's termination insensitive, right?" Now, and then I joked, no, that's not what it really means. Anyway, I had 3 boards. I needed 4, 2 for transmit, 2 for receive, and Todd sent me another one and some additional boards. Anyway, thanks very much, Todd, for that. Ed, DD5LP, who is also Golf 8 Golf Lima Mike, he sent some very kind words about SolderSmoke and some explanations about how the 50th anniversary edition of the GQRP Sprat was produced. Fine business on that, Ed. Bill, AH6FC, sent encouraging words on the podcast and the blog, and good information on solar power from Hawaii. Pretty cool. Mahalo, Bill, mahalo. Michael, AG5VG, he is building, I love it, LCVFOs for 7 megahertz. Michael is definitely on the right track. Good stuff. Thanks. Fine business, old man. That's really good. And finally, Bob, K7ZB. Bob is an electrical engineer by training, but he said that he really liked and Dean always teases me about this, my rather exhaustive treatment of mixers. Dean sometimes says Bill's been posting on mixers for 20 years, trying to understand how the mixers work. But I was really pleased because Bob K7ZB said that even though he has a degree in electrical engineering, he poured over the sections on mixers in the SolderSmoke book, and it was through them that he obtained enlightenment on the subject of how mixers work. Go ahead, Dean.
I think, Bill, that you have to have a certain degree of OCD to enter this hobby.
So, you do. You have to be a bit nuts.
So
here we are.
So maybe, obsessing over mixers for 20 years is not so bad. I don't know. Somebody asked me, well, because people in our club think I'm like this wizard. And I'm like, I know nothing, right? Everything I know, I learned from Pete and Bill, right? And reading the books that you guys recommended. And part of it is just because I'm curious and I'm interested and I read about this stuff. And so you get a little bit of that obsessive compulsive thing to like learn more and more about the thing. Like me with with this tuner right now. It's like, all right, I'm studying all the different variations of tuners and trying things. And it's another form of learning and keeping your brain active.
That's yeah, I know, but every once in a while your wife will look at you and say something like, "Do you think about these things all the time?" And the answer is, well, yeah.
They have doctors for these things, Bill.
Your mother should take you to a doctor. Guys, that brings us to the end. Pete, do you have any final comments here?
No, it's cold out though.
Oh man, cold in Southern California. Not so bad here in Northern Virginia. But I'll say 7-3 from Dean. You got anything up for the group?
I got nothing.
Okay. Thanks very much, guys. Thanks for showing up early in the morning and doing this. 7-3 from Northern Virginia.
7-3 to the left coast.
And 7-3 from Great Falls, just down the road from Bill.
7-3, guys.